So this is your tutorial 8 Fuel Gas System Part 2 from Building Science and Services 2. Okay, we have a few questions here. So this one question is the only theory question for this tutorial. The rest will be calculation. So the first question is asking you to discuss the factors that is affecting the flow of gas pipe. So there's generally 5 factors which affect the gas flow of gas pipe. The first is the internal diameter. So if you have a bigger diameter, then if you're flowing the same supply from a small to a bigger diameter pipe, then your pressure will reduce, which means the flow of the gas will be slower. Okay, the next is the gas pressure. So same like the internal diameter, if you're supplying a low gas pressure in a gas pipe, then the flow of the gas will be slower. Okay, the third is the type of piping material used. So how this material use can be affecting the gas pipe, as far as I know, is the corrosion lah. So usually people will use cast iron, so the gas will not corrode the piping, or even the nature will not corrode the piping. Okay, the fourth is the relative density of the gas. If the gas is very dense, then it's able to occupy less space. So when it's able to occupy less space, you'll be able to transport more gas as opposed to a lighter density gas. Okay, last is the length of pipe and the resistance of fitting. So if you have a very long pipe, by nature loss of energy, the gas will flow slower. So all these factors can affect the flow of gas pipe. Okay, so this is your calculation question. So for question number 2, you have a 25 mm diameter gas pipe with 4 90-degree bend and 8 teeth supplying natural gas to the kitchen in an apartment. So if the net length is 45, you have to find the effective length of the pipe. So you are given 4 90-degree bend, which is this 4, and 8 teeth, which is this. So referring to table 6.2, and you are given 25 mm gas pipe diameter. So referring to 25, which is here, the nominal bore addition to net pipe run, you have 25 mm gas pipe diameter, and then you have 4 90-degree bend, which is 0.3. So you put it here, and then you have another 8 teeth, 0.6, which you put it here. You just do a simple multiplication of 4 times 0.3, 8 times 0.6. You have a set of value, and then you add them together. So this 6 meter is the addition to net pipe run due to this bend and teeth that you have in place. So if what you have on the kitchen in an apartment is the total length which you can physically see is 45 meter, but due to this bend and teeth that you have in place to route the pipe to your kitchen, you are effectively adding additional 6 meters addition, which you cannot see, additional resistance to your piping system. So in actual, if you were to measure the pipe, you may find that you only have 45 meter, but the real effective pipe length, to apply the post formula later, is actually 51 meter due to the additional bends and teeth you have. So for this question 2, you have to find out what is the additional length of net pipe run added due to your bend and T. You have the number of bend and T, multiply them with the table 6.2 of what value you find for the T and the bend, and then you total them up together, and then you add it to your net length of pipe run, which is 45 plus 6, you get 51 meter. So this is how you answer for the question 2. Okay, so for question 3, it's a continuation of question 2. So using Pohl's formula, you have to determine the flow rate of gas in the pipe mentioned in question 2 if the pressure drop measured is 650 meter bar over the 45 meter net length of pipe. So you are given the specific gravity of 0.59. So you have a pressure drop of 650, and then you have a diameter of 25 mm. You have your specific gravity of 0.5, and you have a net length of 51 meter. This is the effective net length. So you have your Pohl's formula here. You put all the information that you have into this formula. D, which is 25 mm, into here and here. H, S, and L. So you have all your factors. All the factors are known. Then it's a simple calculation of finding out what is the flow rate. So in this case, you'll get 112.64 liter per second. Okay, so for question 4, a 25 mm diameter pipe is connecting dwelling with the LPG tank in a condominium. If the design flow rate is 100 liter per second and the permitted pressure drop is 435 bar in this 60 meter long pipe, by Pohl's formula, comment the pipe size is appropriate to be used or not. So you have your H, which is equals to 435 bar, and then your Q equals to 100 liter per second, and your specific gravity 0.59, and your length, which is 60 meter. So you put in all the factors into this Pohl's formula, and then you have to work it out that D is actually equals to 26.69. So which is bigger than 25 mm. So for this question, 25 millimeter is not appropriate lah. Okay, so here is a bit of mathematical calculation lah, which you move the D around so that you can solve what the D is. So if you were to do it, then you'll be able to practice on it lah. Okay, so this is the last question. So for this question, it's still the same, but there's a special statement here lah, which it does not allow more than 10% pressure drop, and then the rest is the same lah. So you have your D, which is 50 mm. You have your Q, which is 150 liters, which is from here. The specific gravity given 0.61. So your pressure drop is not more than 10% of the 300 bars. So which is this. So 30. So you have to put in all the value into here, and then you have to solve it for the length. So the formula is the same, but you have to move it around to solve the question. So at the end of it, you'll find out that by solving the equation, you'll find that L is equals to 41.08 meter. Okay, so that's about it for the tutorial 8. So you have to pay attention to what the question have given to you. The post formula is standard, which is this. Then to solve the question, usually there will only be one unknown, or all the information is given, like the question 4, but he will ask you to check if it's appropriate or not. So that's all for this tutorial 8 question, tutorial 8. So hope you guys understand. Hope it's clear for you guys.